Here we go. Specifically, we're going to learn about their atmospheres most importantly. Mercury has no atmosphere, which is our first planet close to the sun. Venus is the hottest planet, even though it's not the closest. And we're going to figure out why Mars' temperature is a little weird. Okay, so when you see a star, this is what I want you to write down: the title and the facts associated with it. And so let's get started. A terrestrial planet is made of mostly rock and metal. The four inner planets: Mercury, Venus, Earth, and Mars. There are important things you need to know: the greenhouse effect, which is what we're going to talk about. And that's why certain planets are so hot. It's because gases can trap heat, well, just like layers of a blanket. If you have too many blankets, you might get too hot. Think of greenhouse gases in that way. Now we have our sun. It's very large. 1.3 million Earths could fit inside of this, and it's approximately 27 million degrees inside of the core. We have our first planet, which is Mercury. That's the smallest planet. It's the planet closest to the sun. It's very barren. And the reason Mercury uh, is not the hottest is because it is a planet with no atmosphere. Solar wind has pushed the atmosphere off of Mercury, which means it's very hot during the day on the sunny side, but there's no blanket. There's no way to keep that heat. So actually, on the other side, it's negative 280 degrees on the nighttime. So there's no atmosphere because the um, the sun's solar wind has pushed that atmosphere away. So that's important to note. We have Venus, which has a really big atmosphere. It's actually our hottest planet. And that's the important thing to know. Atmospheres can trap heat depending on what's in them and how big they are. All right. It's almost the size of Earth. That's why it's called its sister planet sometimes. Now, why is Venus so hot? Well, instead of having no gases in its atmosphere, it has a huge atmosphere. Its atmosphere, think of all of the air on Earth. Venus is roughly the same size as Earth, but has 90 times more atmosphere. That's 90 times as many blankets. And they're really warm blankets, right? Its atmosphere is 90% carbon dioxide. And carbon dioxide is a greenhouse gas. Think of that as like a down feather blanket, all right? So it has 90 down feather blankets on it, right? Whereas Earth might just have one. It's hot enough that lead on its surface would melt, right? And we have sulfuric acid raining from the skies, but it's so hot that it doesn't even land on the surface. It just evaporates before it gets there. And we have Earth, right? The only known place where life exists. Not too hot, not too cold. And we have Mars, known as the red planet. It's the fourth planet from the sun and the last rocky planet. Now, it's around negative 70 degrees, even though its atmosphere is mostly carbon dioxide, right? So it has that down feather blanket quality, but it's really far from the sun. So its atmosphere is less than 1% the size of Earth. So even though carbon dioxide here can trap a lot of heat, um, it's just too far from the heat source. It's like having one down blanket but going to Antarctica. It might not be enough. So it's very far from the sun. What are these gases? So we're going to do an activity, or we've already done this, that has ozone. All right, we're going to look at ozone. This is a protective layer in our atmosphere and some other atmospheres that can block out harmful rays, harmful UV rays. And that's a really important thing for us to note, right? We have carbon monoxide, which is a colorless, odorless gas and can be lethal. So make sure you've got a carbon monoxide detector, but that's also in certain atmospheres, and fire departments can give you those for free. We have carbon dioxide, a known greenhouse gas, although not the most potent greenhouse gas. Methane is worse, right? But it is around, right? There's quite a bit of it, especially in Venus, right? So that's a very potent greenhouse gas. Methane is much, much more potent. Um, it traps 30 times more heat than carbon dioxide. So it's, I don't know, like wearing a thermal, I guess, a thermal blanket of some sort, you know? So it's quite potent. And then we have nitric oxide, which traps even more, 280 times more heat than carbon dioxide. And if you ever heard of smog, this is what contributes to smog in places like Los Angeles, right? So what kinds of data do spacecraft collect when they travel to other planets? And what do engineers need to do to make sure that data arrives on Earth, right? Um, so we have a few things. We use with satellites false color imaging and remote sensing. Both of these things can provide us with a sense of what the atmosphere is, because remember, each atom and each compound, everything has its own color fingerprint. And so we can get that data using remote sensing and false color imaging. If we have satellites here, we can check to see what atmospheres are like on other planets, which is kind of neat. And so the activity that we're going to do, or that you have done already, indicates this is real data from NASA, and it shows real trends. Its wavelength right here, this might indicate a specific gas, and we might have that same gas. It looks like Venus and Earth have that same gas. It looks like the intensity is much higher on Venus than on Earth, so they might have more of that specific gas, right? And then just, these are some fun videos I'd like you to check out. And here's our summary in case you need it, and I hope that was helpful.